Hello everyone. Today we are going to continue our thermodynamics topic. In previous lecture, we learned about the introductory part of the thermodynamics. Now, in this video, I am going to discuss with you the basic terminologies which are used in thermodynamics, which are very important as far as the concepts of thermodynamics is concerned. Let us start with the three important terms: system, surrounding and boundary. As we know that when we start with the thermodynamics, we need to take or consider some important thing. So how we can define and how we can differentiate all these things in thermodynamic point of view? Let us see. Let's start with one example: the water contained in a beaker. This is one of the best example to show the thermodynamics terms: system, surrounding and boundary. Here, when we consider this water in a beaker, this water is surrounded with the space, and this space is known as surrounding here, and the water that present in the beaker, that is the system. So here we define from this the system as the surrounding. This is the space and the water is present in this space. So this water is a part of this space, and this space is in term of thermodynamics called as a universe, and here the water is present in this universe, which is one of the integral part of this universe. So this water is a part of this universe, and this part of universe is known as a system in case of thermodynamics. From this we can easily define the system. A system in thermodynamics refers to the part of the universe which is under observation, because here we observe only the water in the space. Therefore the water is a part of this universe and we call this as a system. Now what we said to the surrounding, or what we said to the universe, so the other part of the universe other than the system, that means the other part is the beaker, as the beaker is the remaining part of the universe. This is called as a surrounding. So the water is known as a system in case of thermodynamics, and the beaker, this beaker is called as a surrounding, and the rest of part, surrounding and system, other than surrounding and system, is called as a space or universe. So here we have another terminology. This terminology separate the system, that means water, and surrounding, that means beaker. So the term which separate the system from the surrounding, which is imaginary, that may be the physical, this is known as a boundary. So here we have the imaginary bounding which separate the system with the surrounding. So here we have three important terminologies. The system is a part of universe which is under observation. The second one is the surrounding is the part of universe which separates system with the universe, and the boundary, this is the third most important terminology which separates system with the surrounding. Here we have one example: water contained in a beaker. Okay, in this example, water is a system which is part of the universe which is under observation, and the beaker is the surrounding, okay, which has the water in it, and the part of this universe which separates the system with the surrounding, which is the imaginary in this case, or it is physical also, because surrounding is a solid state and the system, what we consider here, water, is a liquid state. So it is physically distinguishable. So the physically distinguishable or imaginary part of this universe is known as a boundary. So this is three important part of the thermodynamics. Along with that, so let us say one general example. This is the one of the application of the thermodynamics. Here we have the piston. So this is the part of the engine. Here in engine, this is the mixture of petrol and gas. This is called as a system. And the imaginary boundary, so this is the dotted line represent the imaginary boundary that separate this system with a part of the engine. So the other body of the engine is known as a surrounding, and the surrounding that contain the system, that means it contain the mixture of gas and petrol. So the gas and petrol is the system in this case, and the body is known as a boundary, body is known as a surrounding, and this system and the body of the engine is separated by one of the imaginary dotted line is called as a boundary. So this is the mechanical system, which is one of the best example which gives the detail about the system, boundary and the surrounding. The next important point in case of thermodynamics is the types of the system. We are going to differentiate the system on the basis of how many phases are there. Let us see, here we have one example of mixture of gases. Here we know that here the gases, mixture of gases that contain different examples of gases, like the gases has oxygen, nitrogen, argon and so many gases. This is the mixture of the gases. If you observe the state of this all gases, the state of the gas is constant, that is the gaseous state, but it has so many mixture of gases, examples of gases, or they trap different gases together. And if we see the nature of these gases, they are uniform throughout. Okay, in a cylinder they are uniform, everywhere it is a uniform, but state of system or phase of system is a constant, that is gases. Only one phase is there, that means the gas phase is there, and this gas phase is uniform throughout this cylinder. So this is type of the system. So the mixture of gases that fitted in a cylinder. So here mixture of gas is a system, the cylinder with the piston is a surrounding, and the imaginary part which separate the gas with the cylinder is the boundary. So here this is the example of system. Here only one phase is there, that is gaseous phase, and this gaseous phase is throughout the same. So this type of system is called as a homogeneous system. So on the basis of the number of phase and uniformity, the system can be differentiated into first homogeneous system. The system is uniform throughout, is called as a homogeneous system. In this homogeneous system only one phase is there, in this case it is gaseous phase. So the other example of this is pure metal. In pure metal only one phase, that is the solid phase is there, and the in case of pure metal everywhere it is uniform. So these two criteria fulfilled by this pure metal case, so this comes under the homogeneous system. The second type of the system is the heterogeneous system. Let us begin with one example, ice in a water. This is one of the system where ice and water, this is the system, and the glass, this is called as a surrounding, and these two are separated by a physical boundary. So this is one of the example of system. When we observe the ice in a water system, we have seen two different phases. One is a solid ice phase and another is a liquid water phase. So these are the two different phases present in this system. So here we have more than one phase. So this is known as heterogeneous system. When system contain such type of more than one phase, then it is known as a heterogeneous system, and this is not uniform throughout. When we see everywhere there is no we have two different phases, not only single phase throughout the glass. So this is called as a heterogeneous system. Here we have another example of the heterogeneous system, the distillation process. In distillation process, in round bottom flask, we have mixture of ethanol and water. So no doubt this is the both has a liquid phase, but when we heat this mixture, then you will observe two different phases. One phase of liquid containing ethanol and water mixture, and another is a gaseous phase. So here in this round bottom flask, you observe two different phases, gas and liquid phase. So number of phases are 2. This is more than 2. Therefore, this is comes under the heterogeneous system. Along with that, in case of condensation, when the gases vapor that come and goes to this condenser, then here you will observe two different phases. One is the vapor phase and another is the liquid droplets, that means liquid phase. So here also two different phases are there. So here this system is the heterogeneous system. Why? Because it has more than one phase, that means two phase. One is liquid, one is gaseous vapor phase. So this is the heterogeneous system. So on the basis of number of phases, we differentiate the system in two categories: homogeneous system and heterogeneous system. In homogeneous system, only one phase is there. In heterogeneous system, more than one phase is there. In homogeneous system, we will find the uniformity, but in case of heterogeneous system, we will have the absence of uniformity. So this is the two categories of the system. Now we can also differentiate system on the basis of the nature of the boundary and how it is sealed. So on the basis of these two criteria, we can differentiate the system in three categories. One is open system, second one is closed system, and third one is the isolated system. Let us see one by one. Okay, start with the open system. As we have, open system is one which can transfer both energy and matter to the surrounding and from the surrounding. Okay, in order to understand this, let's start with the one example of the chemistry. Here we take water in a conical flask, and when we heat that water containing conical flask, then here the heated water is a system and the conical flask is the surrounding. Okay, when we did this process, when we did this operation, then here the water get converted into its vapor and they transfer to the surrounding through this narrow end opening of this conical flask. When the water vapor goes to the surrounding, okay, that indicate the some mass, some matter is transferred to the surrounding. This indicates the transfer of matter from the system to the surrounding. Now the second is when we heat that system, the water, then you will observe the transfer of heat, okay, from the transfer of heat through the glass of the conical flask to the surrounding. So in this case, both matter, that means water, and the energy, that means in terms of heat, can be transferred from the system towards the surrounding. So this is the one of the example which contain or which reflect the transfer of both matter and energy to the surrounding, and we can also take it back from the surrounding to the system. So for this case, we will observe that the nature of the boundary, this is the boundary and the boundary is open. So boundary is open and it is unsealed. We cannot seal this boundary of the conical flask. So nature of boundary is open and uninsulated. Because of that, we can be able to transfer the matter, that means water vapor, to the surrounding, and the heat, as it is uninsulated, it is energy can be transferred from the water to the surrounding through the glass. So because of this nature, this is known as a open system. So because of this, we can say that this is open system in which we can transfer the matter, that means water, from the system to the surrounding, and also heat, that means the energy, from the system to the surrounding, and we can reverse it back also, because of only the boundary is open and unsealed. This is called as a open system. Let us take few more example. A hot water in a kadai. When we see here a hot water in a kadai, you will observe the water vapors that coming out from this kadai. That water vapor is the transfer of the matter from the kadai to the surrounding, and at the same time you will observe the hot kadai. That means the heat is also transferred from the inside kadai to the outside surrounding. So here in this case the both matter and energy is transferred from this kadai to the surrounding. So this is the one of the example of the uh, open system. Let us see one of the example in a chemistry laboratory. We will have one. We will take one test tube. In that test tube, we have taken a zinc metal, and in that test tube, when we add a concentrated HCl, then you will observe the bubbles in that test tube. What it indicates? It indicates that this zinc, when react with the HCl, then zinc chloride is formed, and along with that, the H2 gas is formed, and that H2 gas is coming out in the form of bubbles, and what we observed in our naked eyes. So the H2 gas is coming out from the reaction mixture from the test tube. So that H2 gas is coming out and goes to the surrounding. That means the matter in the form of H2 gas that coming out from the system, that means zinc and HCl, and they coming out and goes to the surrounding. So here it indicates the exchange of or transfer of matter in the form of H2 gas to the surrounding. And when we touch that test tube, you will experience the hotness. That means the heat is transferred from this system to the surrounding. So in this case also the heat, that means energy, and matter, that means the H2 gas, is transferred from the system to the surrounding. So this is one of the example of open system. So in both the cases, in all these cases, the boundary is open. That means in this case the test tube is open, in this case kadai is open, and in this case the conical flask is open, and in all these case the boundary is unsealed. Unsealed in the case, so we cannot here we cannot seal the kadai, we cannot seal the test tube, we cannot seal the conical flask. So this is the open system. Let us see the closed system. The in closed system we have just make one addition, that when we heat the conical flask containing a water, when we heat the conical flask containing water, in this case we can just add one seal on the top of the conical flask. What it how what we have observed here, when we seal the boundary, so that means here in this case we sealed the boundary here. Because of that we trap the water vapors. Because of this we trap the water vapor, and because of that we are not able to exchange the water vapor to the surrounding. That means we cannot able to exchange the matter with the surrounding, but this is unsealed, due to which the heat is transferred from this system to the surrounding. Okay, in this case the matter is not exchanged with the surrounding, but energy is exchanged with the surrounding. Such type of system is called as a closed system. Let us see the examples of another example of closed system. A hot water in a cooker. Okay, so in this case the whatever matter is there that trapped in a cooker, and when we close the lid, that means we seal the boundary, and in this case we trap the water vapor inside the cooker. So there is no any exchange of water vapor to the surrounding, but we can experience the hotness of cooker. That means the heat is exchanged with the surrounding. So in this case matter is not exchanged with the surrounding, but heat is exchanged with the surrounding. So this is one of the type of closed system. Another example is the LPG gas fitted in a cylinder. So cooking gas is fitted in a cylinder. In this case the opening of the cylinder is sealed, as you observed. Because of that there is no any possibility of exchanging this gas with the surrounding, and when we touch the body of this cylinder, then you experience the hotness of the hotness. That means the energy from gas is exchanged with the surrounding. Okay, so this is one of the example of closed system. In this closed system you observe in all cases the boundary is sealed, but it is uninsulated. Because of that, you are able to exchange the matter. You are not able to exchange the matter with the surrounding, but you are able to exchange energy with the surrounding. So this is the closed system. The third important system is the isolated system. So here we also make some addition. In this case of the hot water containing a conical flask, we close the opening of this conical flask. Along with that, we insulate this conical flask with uh, some with by means of glass wool or other material. And because of that, what happens, that water vapor are trapped inside the conical flask. Along with that, heat is also trapped inside the conical flask, and therefore the heat, that means energy, and water vapor, that means the matter, are not exchanged with the surrounding. So such type of system is called as a closed system. In this, boundary is sealed. As is sealed, there is no exchange of energy with the surrounding, and it is insulated. As insulated, there is no any exchange of the energy with the surrounding. Another best example is a hot water in a thermos flask. When we keep the hot water in a thermos flask, and when we close that thermos flask, that means when we close the thermos flask, you seal the boundary. And thermos flask is specially insulated, made up of insulated material. Because of that, we trap also energy inside. So there is no any possibility of exchange of matter and energy from thermos flask to the surrounding. So this is one of the example of isolated system. Also we have another example of coconut. Okay, so this is the naturally occurring isolated system. The coconut water is the system, and the surrounding part is the surrounding, and this is the isolated system, as there is no any possibility of leaking the coconut water from the coconut. Therefore, because of the sealed boundary, and the insulated, it is also well insulated, and because of that, we are getting the normal temperature coconut water. So in this case also, there is not possibility of exchanging energy and matter with the surrounding. So all these both cases, boundary is sealed and uninsulated. Because of that, there is neither matter or nor energy is exchanged to the surrounding or from the surrounding. So these are the three type of the system: open system, closed system, and isolated system. So on all these systems are classified on the basis of the nature of the boundary. There are two categories: sealed or unsealed. On this basis, we can differentiate the system in three categories: open, closed, and isolated system. Thank you.